Dear teacher and students, today let's discuss the wonders of surface processes. The title of my report is Surface Processes Are Amazing. We have two aims and objectives. Firstly, according to the knowledge learned in class, using the remote sensing tools, analyze how the landscape is built for the three locations. Secondly, predict the possible types of rocks in these areas via the given or provided sediment transportation, surface processes, and deposition environment. Let's be geological detectives together. This location, Red Point, is situated in the Badwater Basin, Death Valley in USA. Let's take a look at the current geomorphological landscape and geological setting. The image on the left, produced by remote sensing satellites, shows a valley with intermediate mountains on both sides. The valley floor can see some small alluvial fans in front of the mountains. And in the middle of the valley basin, there is a white reflection, which should be a playa. You can see from the lower right image a series of mountains and valleys are alternating and roughly parallel in this area. In the lower left image, which is a larger remote view, you can see that the region is flanked by tall northwest-southeast rounding mountains to the west and a plateau to the east. Through consulting the data, we know that this area is part of the Great Basin. The Western Mountains are the Sierra Nevada, between 2,000 and 4,300 meters high, and the eastern side is the Colorado Plateau, between 2,000 and 3,000 meters high. Let's look at the surface processes and depositional setting in this area. In terms of tectonic scale, the collision of plates created the Sierra Nevada. The stretching of the crust formed the basin and range topography, alternating between narrow faulted mountain chains and flat arid valleys or basins. Igneous activity associated with the extension occurred from 12 to 4 million years ago. In the valley, high temperature, wind, water, and evaporation are major processes from the landscape. This area has an extremely hot and dry climate. For example, since 1991 to 2020, mean daily maximum was 33.3 Celsius degrees. Average precipitation was 56 millimeters per year. Although precipitation is small, there are occasional floods which play an important role in the landscape and deposition. Badwater Basin is the perfect sedimentary environment. It is a field with sediment, highlighted in light yellow, eroded from the surrounding mountains. Particularly, salt deposited by recurring flood that occasionally submerge the lowest valley floor. The Badwater Basin is filled with a lot of sediment from the surrounding mountains, so there are a variety of rock types. In the alluvial fans, you can find gravel and sand that have been transported by water from the surrounding ranges. On the floor of the playa, we can find halite and gypsum. On the ground and in the surrounding ranges, there may be sandstone, conglomerate, limestone, shale, basaltic lava, quartzite, granite, dolomite, etc. As the remote sensing maps show, this location is in the middle reaches of the Rakaia River in New Zealand. It is about 100 kilometers from the Southern Alps and a few dozen kilometers from the coast. The river lies on the Canterbury Plains. As we can see from the image above, this river consists of multiple channels, forming a braided pattern. Between channels are sand and gravel bars. The bars look black. Let's look at the surface processes and depositional setting in this area. In terms of tectonic scale, the collision of the Pacific Plate and the Indian Plate form the northwest-southeast trend of the Southern Alps, with a total length of 320 kilometers, 17 peaks about 3,000 meters, and more than 3,000 glaciers. The high mountains create a shadow effect, resulting in less rain on the eastern side of the mountains and a low and unstable flow of the Rakaya River. The Rakaya River is an upland river, only 145 kilometers long, rising from the glaciers of the Southern Alps, flowing through the Canterbury Plains into the Pacific Ocean. Since the difference of elevation is large, the water flow is modest, unstable, and relatively fast. According to what we have learned, this river has low competence and low capacity. Large floods drop and stranded during dry seasons. Multiple channels form across a broad valley. Between channels are sand and gravel bars composed of deposited sediment. Braided river and alluvial fans are deposition environments. The riverbed and surrounding plains are rich in alluvial deposits, consisting of gravel, conglomerate, and greenwacke. These deposits are formed from the erosion and transport of rock material from the Southern Alps and other surrounding highlands. Other rocks include limestone and argillite. This location, or red asterisk, is situated in Canary Islands. It is a sea mountain or submarine volcano between Tenerife Island and La Gomera Island. It is also an active oceanic volcano. This area belongs to the Canary hotspot. Currently, a hotspot is the explanation accepted by most geologists who study the Canary Islands. As we can see from the statistical table on the top right, volcanic activity in the Canary Islands has been ongoing, and underwater volcanoes have also been active. The sea trenches surrounding the Canary Islands are primarily characterized by oceanic crust materials and volcanic rocks. According to our previous analysis, the submarine mountains here mainly produce volcanic rocks, mainly basalt, which is the primary composition of the oceanic crust beneath the trenches. It looks dark and has a fine-grained structure. We could also find hyaloclastite and other igneous rocks. Let's sum it up. Surface processes shape the surface of the Earth, involving the interactions between physical, chemical, and biological systems. The rock, especially the sedimentary rock, is a record of geological history. The present is the key to the past. Earth's surface is an ongoing process. Wind, water, plate tectonics, and other ways are still continuously shaping the surface of our planet on a day-to-day basis. Among all, plate tectonics is the most influencing factor. Time brings a great change to the Earth. Here are some of the materials I referred to in my work, particularly thanks to Dr. Penelope for the knowledge she gave us in the course, which was very useful. Thank you for listening of my video podcast.